Friends, this is B. Praveen Kumar, lecturer in chemistry, Government Degree College, Gambhirapet, Rajana Siricilla District, Telangana. I am going to discuss about colloids. Colloids is one of the types of solutions. In colloids, the particle size is 20 to 2000 angstroms. So let us see the important types and parts of the colloids. You can define colloids like this: a homogeneous non-crystalline substance consisting of large molecules or ultramicroscopic particles of one substance dispersed through a second substance. Colloids include gels, sols, and emulsions. The particles do not settle and cannot be separated out by ordinary filtering or centrifuging like those in a suspension. Here, this is the effect caused by the colloids. This is called as the Tyndall effect. This is solution, this is colloid, and this is suspension. As there are three types of colloids, three types of solutions means that is true solution, colloid, and suspension based on the size of the particles. Here the three forms in which all matter exists are solid, liquid, or gas. Colloidal systems can be any combination of these states. A colloidal system is not a true solution, but it is not a suspension either, because it does not settle out like a suspension will over time. Colloids are larger than most inorganic molecules and remain suspended indefinitely. They are large molecules such as proteins or groups of molecules. They have many properties depending on their large specific surface. Colloids are larger than most inorganic molecules. Colloid formation can be classified in two systems: reversible and irreversible. In an irreversible system, the products are so stable or removed so well that the original reactants cannot be reproduced. A reversible system is one which the products can be made to react to reproduce the original reactants. Here we can see the two phases indulged in the colloidal system. One is dispersed phase and dispersed medium. Dispersed phase and dispersed medium. In dispersed medium, dispersed phase is uh, indulged with the dispersed medium. Here dispersed phase and dispersed medium, there are number of different forms will be there. Different dispersed medium, that is external phase, and we will call dispersed phase as internal phase. The constituent found in the greater extent in the colloid, the constituent found in the lesser extent in dispersed phase. Means the concentration of dispersed phase is less and the dispersed medium is high. Further, The classification of colloids will be like this. A further classification is as lyophilic and lyophobic. Lyophilic colloids, solvent attracting colloids. Lyophobic colloids, solvent repelling colloids, or association colloids. A mixture of the two colloids are there. Solvent attracting means lyophilic. Solvent repelling means lyophobic. If water is dispersing medium, it is often known as hydrosol. And we can prepare the lyophilic colloids easily, but we cannot prepare lyophobic colloids as easy as lyophilic colloids. There are two main ways of forming a colloid: reduction of larger particles to colloidal size, or condensation of smaller particles. Example: molecules into colloid particles. This latter generally makes use of chemical reactions such as hydrolysis or displacement. Laboratory and industrial methods make use of several techniques. This page gives a brief overview of some of these techniques, but it should be noted that there are a broad range used in practice. There are two main ways of forming a colloid: reduction of larger particles to colloidal size, or condensation of smaller particles. One of the important types of colloids are emulsions. In emulsions, usually prepared by vigorously shaking the two constituents together, often with the addition of an emulsifying agent. Emulsifying agent means emulsifying agents protects the colloids to be a colloid, but not to become a suspension or precipitate. It avoids to become precipitation, that is called as emulsifying agent. We can use a surfactant such as soap in order to stabilize the product formed. These are the emulsifiers. These are also called as emulsifiers. Purification. Colloids are often purified by dialysis. However, dialysis is the purification process, a very slow process where the aim is to remove a large part or any ionic material that may have accompanied their formation. A membrane is selected that will not allow colloid particles through but will let the solvent and ions permeate through. The method relies on diffusion, osmosis, and ultrafiltration. Purification. Colloids are often purified by dialysis, a very slow process where the aim is to remove a large part or any ionic material that may have accompanied their formation. A membrane is selected that will not allow colloid particles. Next, properties of colloids. The chemical and physical properties of inorganic colloids can be changed dramatically when their size is reduced to a number of nanometers. This effect is due to the increasing importance of the colloid surface. The presence of colloid particles in a solution has only minor effects. on its colligative properties, that is boiling point, freezing point, etc. The presence of colloid particles in a solution has only minor effects. Next, the Tyndall effect. As we have seen the diagram of Tyndall effect in the second slide, unlike solutions, colloidal suspensions exhibit light scattering. A beam of light or laser, invisible in clear air or pure water, will trace a visible path through a genuine colloidal suspension. Example, a headlight on a car shining through fog. This is known as the Tyndall effect. Headlight on a car shining through fog. After its discoverer, the 19th century British physicist John Tyndall is a special instance of diffraction. This effect is often used as a measure of the existence of a colloid. It is visible to colloids as weak as zero point 0.1 parts per million. It indicates as ppm. However, there are exceptions. For example, the effect cannot be seen with milk, which is a colloid. Examples of colloids here. These are just a few of the many examples of colloids. Really, we can see a lot of colloids in our daily life, both man-made and naturally occurring. Aerosols. Man-made example is aerosol sprays, insecticide spray, smog. Natural aerosols is fog, clouds. Solid aerosol. Natural aerosol is smoke, dust. Foam. For foam, man-made example is shaving lather, whipped cream. Next. Examples for emulsions. Man-made is mayonnaise, cosmetic lotion, lubricants. Natural emulsion is milk. Here it is sole. Man-made sole is paint, ink, detergents, rubber. Solid foam. Man-made marshmallow, styrofoam, insultation, Kosh cells. Man-made jellies, butter, jelly. Solid sole, man-made is certain alloys, natural is pearl, opal. Colloid versus crystalloid. You can see the diagram of colloid. Milk mixed with water, colloid. Salt dissolved in water, crystalloid. Here we can see how the colloid is formed with the mixture of water and milk. Here water is colorless and here is milk is in white color. This is called as crystalloid and this is called as colloid. We are adding salt in water. Though we are adding salt, there is no change in color. That means it poses the same colorless only. But here the same water we are mixing the water in milk, that also remains no change. Applications of colloids. Here we can say a lot of applications are there. rubber plating, sewage disposal, smoke screen, purification of water, cleaning action of soap. In medicine, you can use in medicine also, in preparation of medicine, as the every medicine, every syrup will be in colloidal state only, so that it can easily absorb in the stomach. Formation of delta, by these deltas, uh, crops will be grown very easily, and the yield will be high. Artificial rains, we can form the artificial rains with the colloid particles, that are silver iodide particles. We can purify the water. We can use the alum and ferric hydroxide to purify the water. Rubber plating, we can use the um, rubbers that are used as um, what do you call, um, tanning industry. Chrome tanning, chromium salts are used in tanning industry, that is called as chrome tanning. Examples of colloidal systems from daily life, here you can see foams, milk, fog and smoke, detergents, aerosol or aerogel, blood, paints, cosmetics. So, we are colloidals are very essential part in our daily life. You are seeing here milk, paints, cosmetics. Without cosmetics, nowadays, uh, no house is there, or no person is there without using any cosmetics. And also, milk is the daily essential part in our life. So these are the important examples, important importance of colloidal systems, we can say. Detergents also you can use in the daily life. So by this I conclude, especially you can see the examples means sprays, insecticide spray, smog, natural aerosol means fog, clouds, etc. Gels means butter, jelly, etc. These are especially, these are uh, some other examples also there, that is in emulsions. This is the natural emulsion, that is milk, uh, fat which is in the liquid state, it dispersed in the water. Milk, you can see the milk how fat is there. And the crystalloid, this is very lighter solution. This is the difference between colloid and crystalloid. So thank you.